So the next section that we're working on here is ellipses. So 10.2 is the simple ellipses, and in 10.4 we have more complicated ellipses. This is the homework. So let's talk about what we're doing today. We're going to graph ellipses where the major axis, which is the longer axis, is either vertical or horizontal. And we're going to include the foci. Foci is the plural of the word focus. And center and vertices, and write the equation of an ellipse given different information about various things like the point, a point, the focus, the center, the vertex, and so on. Geometrically, an ellipse is the set of all points, the sum of whose distances from two fixed points called the foci. So in this example, these are the foci. And the point on the surface of the ellipse is a constant. So it's hard to illustrate here with my fingers, so I strongly encourage you to go to this link, just copy and paste it into your browser, and it's a really nice animation that shows you the geometrical definition of an ellipse. So now we're going to talk about all the things. So this example, this graph, and this description is an ellipse with the horizontal major axis. So axis, we're used to thinking of x as an axis and y as an axis, but any line can be an axis. So the major axis in this case is horizontal. So the major axis would go through the center of the ellipse horizontally. This is the general equation of an ellipse. Notice that we have two terms with a plus in between. That's important because hyperbolas are different. Two terms, and they add up to 1. So this is going to become important later. A is always bigger than B, and they're both positive numbers. So notice that the a squared term in this example is in the x term, and the b squared term is under, or the denominator of, the y term. And that occurs when the ellipse has a horizontal major axis. So what's really important to note here is that a is bigger. That's what this inequality says. That's really important. So A is always the larger of A and B. All right, so how do you find the center? It's very much like a circle or a parabola. So if you have it in this form, the center is HK, where H and K are the opposite signs of what you see. So on the graph, this would be the center. So this would be the point HK that you got from here. So the horizontal axis has length 2 times A, so A is the square root of the denominator, and the vertices, so the vertices are these points where the curve turns, so it's curving to the right, and now it's going back to the left, so it turns here, and likewise here, turning one way, turning the other way. So vertices are where the curve changes direction. So these are the vertices, 2 of them. And how do you find them? So the vertices are a distance of A away from the center. So this distance between the vertex and the center is distance A. And this distance between the vertex and the center is also A. Therefore, if you know what the center is, notice the y-coordinate, so K, is the same along this line. So this vertex would be the point H minus A. We subtract A to end up over here, and the height is the same. So this vertex is going to be H minus A comma K. And then this one would be, we take the H and we'd add A, so this would be H plus A, comma k. That's this vertex. Now, we do have two other vertices because the curve changes direction both here and there, so these are also vertices. So the h, the horizontal component of the point, is the same, but the height, the k, the y value is different. So this vertex is h, which is the same, and then we take this y value, the k, and we add, what are we adding? We're adding b. So this distance is b. So this point would have a y component k plus b, and this vertex, the x is staying the same, so h, and the y component is moving down a distance of b, so that would be k minus b. So that's what this says over here. So this distance here is also b. So far we have 4 vertices, and once you have them, you can make a nice smooth ellipse, which we think of as an oval. And then we also need the foci. So those are the points where if you tied a string to it, you could drag it around and draw your ellipse. So we have to figure out what those are. So it turns out, I'm going to kind of do this backwards a little bit. The distance between the center and the foci is the plural of focus, is a distance of c, and we'll calculate c in a second. So this distance between the center and the focus, I'm going to call this F2 for focus 2. That distance is c. So we know how to calculate it once we know what c is. I'll go back and tell you about that. So the x component is going to change by adding c, and the y component is going to stay the same. I'll finish this up while I'm over here. So the other focus just goes the other way, a distance of c. So that's also going to be a distance of c. And this focus, I'll call it F1 for focus 1, is at, we're going to take the x component h and subtract c, and the y component of that point is going to stay the same. Well, how do we find c? So c squared is equal to a squared minus b squared. So the denominators, and notice that since a squared is the bigger one, when you take a squared minus b squared, you're going to get a positive number. So that's important because otherwise you can't solve it. So a squared is the bigger number. And when we have one in this form where the bigger number is under the x term, we get a horizontal major axis. So a couple other things here. The length of the horizontal axis. The horizontal axis is the distance between the two vertices on the horizontal direction. So I'll just do the distance here. So the distance of the horizontal axis is a, and then another a, so 2a. Now let's talk about the vertical axis. So that's between these two vertices. I think I can squeeze that in over here. So the distance of the vertical, I'm abbreviating, axis is b, and then another b, so 2b. All right, and so that is all of the things. So now I'm going to flip the page, and we're going to do all of the same things to describe and graph an ellipse with a vertical major axis. And there's really only one thing that's different, so I'm going to do the other one a little bit faster. So we're going to turn the page. Let's look at an ellipse where the major axis is vertical. So vertical major axis, again, that's the longer axis. You're going to notice that almost everything is the same in here. The one difference is that b squared and a squared have swapped places. So notice a is always the larger of a and b. So the larger number is the denominator on the y term. Since the denominator is the larger on the y term, that means the y-axis is the major axis. So let's start by finding the center. The center is always HK. Notice opposite signs. So this is the center, HK. And now we need to label or identify the vertices and the foci. So let's do the major axis vertices first, so the vertical axis. So the denominator on the vertical axis is A. So that means the distance between a vertex and the center on the major axis is a distance of A. So that means this vertex has coordinates. The x-coordinate stays the same, and the y-coordinate changes, so we take k and add a to get the upper vertex. So that's this one. And then we're going to find the one below it down here. So this distance between the center and this vertex is also a, the longer distance. So that vertex is going to have coordinate h stays the same, and k gets moved down a distance of a. Now let's do the horizontal vertices. So this vertex on the right is going to move the x-coordinate, the h, to the right a distance of b, the square root of the denominator under the x term. So h plus b, and the y-coordinate is the same as the center. So that distance is b. And likewise over here, the distance between the center and this vertex is b. So that vertex is going to have coordinates h subtract b to move to the left, comma k, the height is the same. So those are our vertices. So now let's talk about the foci. So the foci are always along the major axis, and the distance between the focus, I'll call this F2 to go from bottom to top, and this F1. The distance between the focus and the center is always C. So this is C. I'll label these points first. So the x-coordinate stays the same, and the y-coordinate in this case moves up by C, and in this case moves down by C. And remember, you find C by taking a squared minus b squared, where a squared is always the bigger number. So it's the denominator under the y in this case. So there are the coordinates of the foci. And now we're going to move on and look at some more worked examples. So let's work on graphing this ellipse. So the first thing I'm going to do is identify which of the denominators is larger, and that's going to be a squared. So the denominator on the x term is larger, so that's going to be the a squared term. So the other one is the b squared term. That's very important that that's the larger one. Since it's under the x term, that means that this is going to have a horizontal axis that's larger, so the horizontal axis is the major axis. So let's start with the center. So the center is HK, so it's going to be 2, negative 3. And I'm going to right away label that. So that's the center. And then let's work in the horizontal direction first. So since a squared equals 169, that means a equals 13. So I'm going to find the vertices in the horizontal direction first. So there's a vertex to the right of it. So I'm going to take the x-coordinate and add 13 and keep the y-coordinate the same. So that would be 15, -3. So there's a vertex there. And then there's another one when we move the x-coordinate of the center to the left 13 by subtracting it. So that gives us -11, -3. So -11, -3, so that's a vertex. Now I'm going to work in the vertical direction. So since b squared equals 144, that means b equals 12. So I'm going to find the vertices in the vertical direction. So there's a vertex up from the center. So I take the 2 and I add 12. Oh, vertical direction, sorry. The horizontal direction stays the same. And we add 12 to the vertical component, the y. So we have the point 2, 9. So that's a vertex straight up from here. So that's a vertex. And then we have another one where we start at the center. We don't move in the x direction, but we take the y and we move it down by b, so down 12. So that would be 2, -15. So that vertex is right here. Now, we do have enough information to graph it, but then we're going to put the foci on here. So it almost looks like a circle, but not quite. This direction has a larger axis than this direction. So let's connect it with an ellipse, so an oval shape. So there's my ellipsis. Again, almost but not quite a circle. And now I want to work out the foci. So the foci always go along the major axis, so they're going to be along the horizontal axis. So I need to find c. So since c squared equals a squared minus b squared, and a squared is always the bigger one, c squared is equal to 169 minus 144. So c squared equals 25, so c equals 5. So where are my foci? So there's one, focus, always start at the center, and in this case we're moving horizontally because that's the major axis. So I take my 2, and I'm going to go to the left first. So move it to the left 5 and keep the y coordinate the same. So that would be at -3, -3. I'll call that F1. So -3, -3, so that's F1. And then there's going to be another one at horizontal coordinate of the center, and we're going to move right 5 and keep the y coordinate the same. So that would be 7, -3. So 7, -3. So that's F2. And now we have all the things on the graph, and we also want to state the length of the major and minor axes. So the major axis, that's the horizontal one, has length. It's always twice a. So a is this distance. So remember a was 13, so it's twice 13. So 26. And the minor axis, so that's the vertical axis, is going to be twice this distance, and that was b, which was 12. So the length is going to be twice 12, so 24. So you can see that they're very similar, which is why it looks almost like a circle. All right, we did all of that. So we have one more question here. So the directions are to find the equation of the ellipse with these two vertices and these two foci. So you might be given different information. So for me, I'm a visual person, so I always try to get some kind of a diagram to help me sort out the information. you're going to have to take what you have and figure out what the missing pieces are in order to write your equation. So I'm going to do a super rough sketch of the ellipse. See how I have to make a rough sketch of the ellipse? I'm going to start right away with the information that I have. So there's a vertex at -7, 3. So I'm going to call this -7 and this 3. So there's a vertex, -7, 3. There's another one at 3, 3. So if I call that 3, this is 3, 3. Now it's super rough sketch. Okay. And then we have some foci. So there's a focus at -6, 3. So that's a focus, -6, 3. And there's another one at 2, 3. So that's here. So another focus at 2, 3. Okay, I've got all the information on the graph. So I know that the horizontal axis is the longer axis because the foci are always along the longer axis. Did you notice that from before? So I know that the horizontal axis is the major axis. And that means that A is the denominator on the x term. And I might be able to figure out what A is. So I think we should start by finding the center. So let's find the center. So the center is halfway between two vertices that are on the same axis, and it's also halfway between the two foci that are on the same axis, so I could go at it either way. So I'm going to take the vertices. So it's the midpoint between -7, 3 and 3, 3. That's my two vertices. So the midpoint formula says I take the coordinates and add them and divide by 2. And I take the other coordinates, the y coordinates, and add them and divide by 2. So that's going to be my center. So the center is -2, 3. So let's see if that corresponds to what it should look like. Does that look right? Looks right to me. -2, 3. Okay, so I've got all the information about my horizontal axis. So let's start building our equation, because that was the goal. So I have x minus h squared over a denominator plus y minus k squared over a denominator always equals 1. This is a plus, that's important. So let's see, I do know hk because I have my center now. So it's x minus h, so minus -2, so plus 2, y minus k, so y minus 3. Now, the denominator under the x term is going to be a, because we know that the horizontal axis is the major axis. And a is always, or each of those, a and b, is the distance between the vertex and the center. So this distance is a. So let's calculate a. The y coordinates are the same, so a is going to be -2 minus -7. So that'd be 5. So since a is 5, a squared is 25. So we got that. Now let's see if we have enough information to figure out b. Once we have that, we've got the whole equation, and we almost have the graph. We're just missing the stuff about the vertical axis. So I think we're going to have to work with C to find B, because we don't have any information about the vertical stuff. We only have the horizontal, the things along the horizontal axis. So let's figure out what C is. So C is always the distance between the center and a focus. So let's work on this one. Either one would do it because it's the same answer. So that distance is C. So let's figure out the distance between the center and this focus. So the y coordinates are the same, but the x coordinates are different. So C is going to be -2 minus -6. So that would be 4. So now that I know C is 4, I can hopefully find out b. So our equation was always c squared equals a squared minus b squared, where a is always the bigger one, so we get a positive on the right. So we have 4 squared is equal to a squared was 25 minus b squared, and we don't know what b squared is. So let's work this out. So we have 16 equals 25 minus b squared. So I'm gonna, sorry that I spilled over into this, I'm gonna jump down here. 16 minus 25 is equal to negative b squared. So this is negative 9 equals negative b squared. So 9 equals b squared, and a and b are positive, so that means b is 3. But I really need the 9 for the denominator, so this denominator is b squared, which is 9. So I have my equation. But since it told me to make a rough sketch, I have everything on here except for the 2 vertices in the vertical direction, so I'm going to find the rest of the vertices in the vertical direction. So there's going to be one that goes up from the center a distance of c. So if I start at the center and I keep the x coordinate the same, and I take the y coordinate and I add c, which is 4, that will get me the vertex on the top. So that would be negative 2, 7. And if I take, I'm going to write it down and then I'll plot them. The vertex, the center again, so negative 2, so don't move in the x direction, take the center and move it down 4, that will give me the other vertex, which is negative 2, negative 1. So I have a vertex at negative 2, negative 1, and I have another one at negative 2, 7. Draw this in a different color. So I'm making a nice oval shape connecting my vertices, and there it is. It's beautiful.